Hello everyone, we're studying numericals based on the lesson motion in one dimension. Okay, we have finished studying 3 numericals and we will continue with the rest. Let's see question number 4. A train first travels for 20 minutes with a velocity of 20 km per hour and then for 30 minutes with a velocity of 30 km per hour in the same direction. Okay, remember that the train is traveling in the same direction. What do we have to calculate? There are two things we have to calculate: the total distance traveled and the average velocity of the train. Okay, it's type T. I hope you don't mind with the average velocity of the train. Let's see how to solve it. First, we have to write what is given in the question. Time is given as 20 minutes, but what do we have to do? Velocity is mentioned in kilometer per hour, so we have to convert what? We have to convert minutes to hours. And how can we calculate it? By dividing it with 60. Right, so 20 divided by 60 is 1 by 3. So 20 minute is equal to 1 by 3 hour. Okay, we will just mention it as first phase of time and first phase of velocity, t1 and v1. Alright, so the velocity is 20 km per hour. Now let's see the second phase of traveling. t2 is 30 minutes. Right, so we have to convert this minute to hour. How do we convert? By dividing it with 60. So 30 divided by 60, after you cancel this, you will get it as 1 by 2 hour or half an hour. Alright, so t2 is half an hour and v2, the second phase of velocity, is 30 km per hour. t2 is half an hour. So here we just had to calculate the time. The reason is because the units were different. So we had to convert minute to hour. Okay, now let us solve it. We have to find distance traveled, and you know the formula very well: velocity into time. Okay, distance traveled is equal to velocity into time. Therefore, the first phase is S1, let's say distance 1, is equal to v1 into t1. Okay, now when we replace the values, we will get the answer as, we have to cancel it. Alright, so your v1 is 20 km per hour and t1 is 1 by 3. When we further solve this, we will get it as 20 by 3 kilometer. Right, we'll just keep it as fraction. We'll just keep S1 as 20 by 3 kilometer. Now let us solve the second phase, that is S2. S2 is equal to V2 into T2. So second velocity is 30 km per hour into T2 is 1 by 2, half an hour. So when you cancel it, you will get it as 15 km. So our S1 is 20 by 3 km and right, V2 is 30 km per hour and T2 we just calculated it as half an hour. And after we multiply velocity and time, we get it as 15 kilometers. So the total distance traveled will be S1 plus S2. We just replace the values, we add it, and then we will get the total distance. So therefore S1 is how much? S2 is how much? S1 is 20 by 3 kilometer plus S2 is 15 kilometer. We'll use the LCM method to solve this. I'm sure that all of you know how to do it, but when we simplify it further, we will get it as 65 by 3. So let me just help you to understand how did we get 65 by 3. I'm sure most of you know how to do it. 20 by 3 plus 15. By default, the denominator is 1. LCM is 3. Right, so 3 ones are 3, 20 ones are 20, 1 threes are 3, and 15 threes are 45. When you add 20 plus 45 is 65. That's how we got 65 by 3. 65 by 3. Now this answer is in fraction, right? The total distance here is, we have calculated till fraction. Let us solve it further. Now when we divide 65 by 3, we will get it as 21.67 kilometer. So this is the total distance, 21.67 kilometer. I hope you have understood this. Now let us solve the second question. We have to find total time taken. Okay, so total time taken will be T1 plus T2. We already have the values of T1 and T2, so we'll just have to replace it. The value of T1 is 1 by 3 hour, and the value of T2 is 1 by 2 hour. Okay, we'll just replace it here. So we got it as 1 by 3 plus 1 by 2. Now when we simplify it, we will get it as 5 by 6 hour, right? And so therefore, average velocity, you know the formula very well, total distance by total time taken. Okay, that is S by 2. Now we'll replace the values here to find the average velocity. Therefore, average velocity is equal to total distance traveled by total time taken. That is equal to, or we can write it as S by T. So the total distance traveled is 21.67 kilometer. That is the total distance. We just calculated it. And total time taken is 5 by 6 hour. We'll simplify this, and I will just help you understand how to simplify it. 21.67. What are we going to do is we have to remove the decimal. Okay, so I'll erase it and I will write this number without the decimal. 2167. Now we know that the decimal is in 100th place value, so I've written it as 2167 divided by 100 by 5 by 6. Now the rule, you remember the rule that when we have to multiply the fraction denominator, we have to reciprocal it, right? So 5 by 6 will be reciprocaled. So 2167 divided by 100 into 6 by 5. And when you further simplify it, when you calculate it, you will get the answer as 26.004 kilometer per hour. So that is the average velocity. 26 kilometer per hour is the average velocity. Now let us see numerical number 5. The velocity of an object increases at a constant rate from 20 meter per second to 50 meter per second in 10 seconds. Find the acceleration. Let's see what is given in the question. Right, the initial velocity is given, that is 20 meter per second, and final velocity is given, and time it takes is 10 seconds. We'll use the formula of acceleration, final velocity minus initial velocity divided by time. We'll just replace the values to get the value for acceleration, to get the value of acceleration. Alright, so we get it as 50 meter per second minus 20 meter per second divided by time, as mentioned in the question, is 10 seconds. I hope you're understanding this. Now when we subtract 50 minus 20, we will get it as how much? So acceleration is equal to, how much is that? 30 meter per second, right? 50 meter per second minus 20 meter per second. 30 meter per second divided by 10 seconds, we can simplify it. We can cancel it to get the acceleration. So 30 divided by 10 is 3. By this we know that the acceleration is 30 meter per second. Okay, 30 meter per second. Let's see question number 6. A pebble, a small stone, a pebble thrown vertically upwards with an initial velocity of 50 meter per second comes to a stop to 5 seconds. Find the retardation. Retardation is just the opposite of acceleration, which is also denoted by negative sign, or it is also called as negative acceleration. Let's see what is given in the question. Initial velocity is given 50 meter per second, and final velocity, it will be of course 0 second because it stops after 5 seconds. The time after which it stops is 5 seconds. We'll use the formula of acceleration, final velocity minus initial velocity divided by time, right? So according to what is given in the question, final velocity is 0, initial velocity is 50 meter per second, and time is 5 seconds. So we get it as minus 50 divided by 5, right? And when you cancel it, you will get it as minus 10 meter per second. So when we see that minus sign, we understand that it is retardation. Hence retardation is equal to 10 meter per second square. I hope you have understood these numericals. Keep learning and keep practicing to understand it much better.